In this video, we're going to take a look at exam revision for series and summation. So what we're going to do is just take a look at some exam style questions for series and summation. There won't be too many questions featured in this video, only because it is quite a short topic and chapter. So I don't want to run through too many questions and make it quite, repetitive, but just explain those key concepts then for series and summation. So as always, pause the video, have a look at the questions they appear, and double check that your solution matches what we get on the screen. So other than that, I think that's everything that we need here to get started. So let's begin now with question 1. Starting off with question 1 here then, we've been given the summation of r from r equals 1 to n is equal to 300, and we're asked to find the value of n. So quite a nice question here to get us started. So where do we begin? Well, the summation of r from r equals 1 to n, this is a standard result. So this is the summation here at the first n natural numbers. So the standard result here that you should be familiar with. Let's just write this down. So from r equals 1 to n, this is equal to n over 2, or a half n, times n plus 1. Okay? So in this case then, if the summation of r from r equals 1 to n is equal to 300, what I can see then is n over 2 times n plus 1 must also be equal to 300. We've got n over 2 times n plus 1, that's equal to 300. So straight away, I want to get rid of this fraction here, this n over 2. And to do that, I can times through by 2 here on both sides. So on the left-hand side, I'm going to get n times n plus 1. On the right-hand side here, then 300 times 2 would give me 600. Now, what I can see straight away as well here is when I expand this bracket here on the left-hand side, I'm going to get a quadratic equation. So what I'm also going to do here is subtract the 600, just because I want to set this quadratic equal to 0. Okay, because once we do that, we can attempt to solve for n then. So I'm going to get n squared plus n. So we get n squared plus n there, minus the 600. And that's all equal to 0. Okay. So from here now, what I want to see is whether this factorizes. Okay. If this does factorize, it will save us quite a bit of time. We don't have to, complete the square or use the quadratic formula. So that'll be nice if it does. If it doesn't, then we'd have to use one of those two methods to find the value of n. Now, in this case, this does factorize, so quite a nice question. So what you should get here when you factorize this is n minus 24 in one bracket, and then in the other bracket here, you should get n plus 25. And that is equal to 0. So from here then, we get two solutions for n. Now, obviously, we only need one solution here. And the solution that we need here is the positive solution. Okay, so that would give us the positive value of n. In this case then, we get this from this bracket here. And we can see then that n must be equal to 24. Okay, so obviously n can't be equal to minus 25. It must be the positive value here. So therefore n is equal to 24. And that gives us the solution there to question 1. Moving on to question 2, now we've been asked to evaluate the summation of r times r squared minus 1 from r equals 1 to 20. So where do we begin here? Well, the first thing that I want to do here is get rid of this product here. Okay, so r times r squared minus 1. We can easily get rid of that by expanding out. So obviously this will remain a summation from r equals 1 to 20. So r times r squared, that would be r cubed. We've got r cubed. And then r times minus 1, that would be minus r there. Okay. So the next thing that I'm going to do here now is apply linearity. I'm going to split this up. So we can now write this here as the summation of r cubed. So r cubed from r equals 1 to 20. Minus then the summation of r, again from r equals 1 to 20. Okay. And from here then, this is a lot easier now to actually evaluate. So in this case, the summation of r cubed and the summation of r are both standard results that you should be familiar with. So let's just recap those to begin with. So the summation then of r cubed from r equals 1 to n. This is given as n squared over 4. So I've got n squared over 4. And we times that here by n plus 1 all squared. Okay, so that's the summation of r cubed from r equals 1 to n. What about the summation of r? Well, we already saw that for the previous question. So from r equals 1 to n, this is given as n over 2 times n plus 1. Okay. So what we want to do here is actually evaluate the summation then of r cubed from r equals 1 to 20. So all I'm going to do here is use this result, but rather than using n, we're going to replace n here with our limit here of 20. Okay. So what I'm going to get here then is 20 squared over 4 and by 20 plus 1 all squared. We've got 20 squared over 4. And like we said, we times this here by 20 plus 1. And that's all squared. And now we subtract here. So minus. So we've got the summation here of r from r equals 1 to 20. So again, just using this standard result here, but rather than using n, we now replace that with 20. So it's going to be 20 over 2 times 20 plus 1. So minus 20 over 2 times 20 plus 1. Okay. All you need to do here now is just evaluate this on your calculator. So 20 squared over 4, that would be 400 over 4, so that would be 100. So then we've got 20 plus 1 all squared, so that's 21 squared. Then minus here, so 20 over 2 is 10. We've got minus 10 times 21. And like I said, just put all of this into your calculator. You don't even need to write this line, but just to make it kind of clear what you should get. So like I said, just put it into your calculator. And what you should get here then, is, basically if you do all this correct, is 43,000. So 43,890. Okay. And there we have it. So that gives the solution there to question 2. Moving on to question 3 now, we're asked to find the value of the summation of r plus 3 times r plus 5 from 1 to 60. So where do we begin here? Well, the first thing that I'm going to do here is get rid of this product. And we can do that by simply expanding these double brackets. So we'll still have a summation. And my limits won't change here. So from 1 to 60. So expanding these double brackets here, hopefully nice and straightforward. We get r squared. I get 5r and 3r, so a bit 8r there when we simplify. And then finally 3 times 5 gives me 15. Okay. Now what I'm going to do next here is basically take the summation of this full expression. I'm going to split this up then using linearity. So rather than this being the summation of this full expression, I can split this up now into 3 individual summations. I get the summation here of r squared from 1 to 60. And we need to be slightly careful for the AR here. So the A, we basically apply linearity here, and essentially we can just factor that out in front of the summation. We get plus 8 lots of the summation here of r from 1 to 60. And then we do the same here with the 15. So with the 15 here, I can bring the 15 out in front, and then we're taking the summation of 1. I get 15 lots of the summation of 1 from 1 to 60. Okay. And at this point here, then, it's a lot easier to actually find this full summation now because we've used linearity and split this up into 3 individual summations. Okay. So these are all standard results as well, so it just makes working with these a lot easier. So for the summation of r squared from 1 to n, well, this is given here as n over 6 times that by n plus 1 and times that by 2n plus 1. So that's the summation of r squared. But the summation of r, I've already seen this a few times now, so you should be more than familiar with this. This is given as n over 2. Then we times that by n plus 1. And then finally, for the summation of 1 here, just in case you're not familiar with this, again from 1 to n, this is simply given as n. Okay? So what we're going to do here is use these standard results and just basically replace n then with 60. And this will evaluate each individual summation. Okay? So for the summation of r squared from 1 to 60, that's going to be 60 over 6 times 61 times 121. So all I've done there is just substituted n equals 60 into this standard formula here. So like we said, then we get 60 over 6. And what I'll do here is just put each one in a bracket just so it's clear. I've got 60 over 6. We then times that by n plus 1, where n is 60, so that's 61. And again, just replacing n here with 60, so 2 times 60, 120, plus the 1. I get 121 there. Now just be careful here with the middle summation. We need to times all of this here by 8. So I've got 8 lots here. And again, just using our standard result here then, I'm replacing n with 60. I get 60 over 2, so that's 30. I'll write it out in full, so I've got 60 over 2. And I times that here by 60 plus 1, so that's 61. And then finally, I've got 15 lots here. I'm not too sure why I did that in square brackets. Let's do it in round brackets here. And then finally, I've got 15 lots here. So plus, and again, I'll do it in brackets. So the summation of 1 from 1 to 60, that would simply be 60. Okay, just like we can see here for the standard result. I've got 15 times 60. Okay. So now what I'm going to do here is just evaluate each bracket individually. At this point here, you can just simply use your calculator. But what you should get here then is 73,810 for the first bracket. And for the second bracket here, don't forget you need to times all this by 8. So I get 14,640. And then finally for 15 times 60, I get 900. And finally, just evaluating this summation here, I'm going to get 89,000. So I get 89,350. Okay. And there we have it. So that's the solution there to question 3. And finally then, if we take a look now at the very last question here, question 4. So for the first part, part A, it says using standard results where appropriate, show that the summation of 6r squared plus 8r plus 1 from 1 to n is equal to n times 2n plus 3 times n plus 2. So where do we begin for part A here? Well, to begin with here for part A, what I'm going to do is I'm going to take this quadratic here and split this up now into 3 individual terms. So what I can do then is take the summation of those individual terms. So for example, 6r squared here, we can use linearity. And I can write this then as 6 lots of the summation here of r squared from r equals 1 to n. Okay. Doing the same here now with the r term here. So AR, we can bring the a out in front. So I get plus 8 lots the summation of r from r equals 1 to n. And then finally for the plus 1 here, nice and straightforward, it's simply going to be the summation of 1 from r equals 1 to n. Okay. So from here now, this is just using standard results. So the summation of r squared here, we've already seen this. The summation of r again, we've already seen. And then the summation of 1 again, all nice and straightforward. So if I've got 6 lots here, the summation of r squared, and what have we got? Well, it's going to be 6 lots of the standard result here for r squared. And this standard result is given as n over 6. So it's n over 6. And we times this here by n plus 1. And then by 2n plus 1. Okay. So that's the first part done there. Then for the second summation here, so 8 lots of the sum of r from r equals 1 to n. Again, it's just going to be 8 times by this standard result. So 8 lots of n over 2. And we times this here by n plus 1. Like so. And then finally for the sum here of 1 from r equals 1 to n, that is simply given as n. Okay. That's going to be plus n there. So what I want to do here now is simplify as I go along. So if I've got 6 lots of n over 6 times n plus 1 times 2n plus 1, the 6's here will just cancel because it would be 6n over 6. So I'm just going to get left with n there. I get n lots of n plus 1 times 2n plus 1. Like so. Doing the same here now with this bracket here. So I've got 8 lots of n over 2 times n plus 1. So I'm going to get 8n over 2, which is 4n. So we get plus 4n there times n plus 1. And then finally we've got the plus n here at the very end. Don't forget that. We've got plus n. So what can we do next here? So like you can see, we've still got a bit of work yet till we get to this required form. But what I notice here is I can factor an n out. So if I factor an n out here, what would I get? If I factor the n out, I get n lots. I'm going to get n plus 1 times 2n plus 1. So n plus 1 times 2n plus 1. We then get 4 lots of n plus 1. So 4 lots of n plus 1. And then finally, if I factor the n out, I'm just going to get left with plus 1 there at the very end. Okay, like so. So from here now, when I look at the required form here, what I notice is it's n times 2n plus 3 times n plus 2. So these double brackets here, if I just think about this for a moment, if I was to expand those out, I'm going to get a quadratic there. Okay. And what I notice here is I've got n plus 1 times 2n plus 1. So that's going to give me a quadratic here. I've got 4 times n plus 1. I've got the plus 1 here. So what I'm thinking at this point here is if I expand the brackets here inside the square brackets and simplify everything, hopefully what I'll get here is the expanded form of these double brackets here. So let's go ahead and do that and see what we end up with. So I've got n lots here. So n plus 1 times 2n plus 1. So I'm going to get 2n squared. I get 2n squared. I've got n times 1, so that's n, and I've got 1 times 2n, so n plus 2n gives me 3n. I've got 1 times 1, which is 1. That's the double brackets expanded. We then got 4 times n, which is 4n. 4 times 1, which is 4. And then finally got the 1 here at the very end. So what I can do now is simplify everything here inside the square brackets. So I get n. Got 2n squared, can't do anything with that. I've got 3n plus 4n, so that's going to be 7n. I've got 1 plus 4, which is 5, plus the 1, giving me 6 there. Okay, like so. And now what I've got here is 2n squared plus 7n plus 6. What I'm hoping here now is that if I factorize this here, I get 2n plus 3 and n plus 2. And what we find then is we do indeed get that required form here. So therefore what I get here then is n times 2n plus 3 times n plus 2. Okay, as required there. And there we have it. So that's the solution to part A. Obviously, you could verify that by expanding out 2n plus 3 and n plus 2. Seeing if you get 2n squared plus 7n plus 6, which indeed you will do. But just if you want a quick little check there, that's something you can do. So there we have it. So that's the solution to part A. So what I'm going to do now is I'm just going to clear the screen here. In fact, let me try and do it over here on the left-hand side. We should have just about enough room here, I think, for part B. So for part B then, it says, hence or otherwise, find the exact value of the summation of 6r squared plus 8r plus 1 from r equals 15 to 40. So how do we answer part B here? Well, the fact that it says hence or otherwise would suggest that we're going to use the answer in part A to help us answer part B. So we have to be slightly careful here because the summation doesn't go from 1 to 40 in this case, it goes from 15 to 40. So we need to be very, very careful for that. So in this case here, so let me write out the actual summation here. So I've got 6r squared plus 8r plus 1 from 15 to 40. So like I said, we need to be very careful here now. So how would I evaluate the summation here now when it doesn't begin at 1? So what I need to do is actually take the full summation from 1 to 40. And what I'm going to do is I'm going to subtract the summation then from 1 to 14. So what that would then leave me with is the summation from 15 to 40. So like I said, this would look like then the summation here of this here, this bracket. I'll just put a little star there just to note that it's this from r equals 1 to 40 minus then the summation here again of this original bracket here from 1 to 14. Okay. And like I said, when you perform this subtraction here, this difference of these series, or the summation, what it leaves us with then is the summation from r equals 15 to 40. Okay. Now, with it being a hens or otherwise, like we said, we're going to use part A to help us. And the reason why is because I can simply use this result here then. Okay. So for the sum from 1 to 40, we're going to use this result here and just replace n with 40. Okay. So let me do it underneath here. Like we said then, I'm going to get 40 times 2 lots of 40 plus 3 times 40 plus 2. It's going to be 40. So 2 lots of 40 is 80, so it's going to be 83. And we times that by 40 plus 2, so that's 42. So what I've got there is the summation from 1 to 40, just replacing n with 40 there. And then we subtract here. So now doing the same here, but replacing n with 14. It's now going to be minus 14 times 2 lots of 14 plus 3 times 14 plus 2. So I'm going to get 14. 2 lots of 14 is 28, plus the 3 gives me 31. 14 times 31. And then finally, 14 plus 2 is 16. Okay. So at this point here now, just simply use your calculator to evaluate this here. So if you do all of this correctly here, what you should get then for the final answer is 132,496. Okay. 132,496 there. So like you can see, we have to be very careful just in case the summation doesn't actually begin at 1. But remember, it's not too challenging in that case. All we do is we consider this difference here. Just get rid of everything below where we start here. And that gives us the actual summation that we need. Okay. But there we have it. So that was the solution to part A there. That was the solution to part B. And that gives the solution then to the very last question, question 4. And that actually brings the end of this video on exam revision for series and summation.